Okay, so in this last section of Module 2, we will be discussing shortly what are the risks that are specific for battery production. Safety in battery production is crucial, especially because neglecting any safety measures in batteries production can lead to significant fires and explosions. This during manufacturing process at the end can cause significant financial losses, as well as, for instance, the production downtime. Also, the workers are going to be exposed to hazardous materials and high risky processes, making safety protocols essential to protect their health and as well their well-being. And finally, as safety incidents in battery production can also damage the credibility of the company and at the end affects the overall customer trust in the technology that we are using. So let's take a closer look at the different manufacturing steps of lithium-ion batteries. Each step of the production process will come with unique risks and require careful management and robust safety measures. I will go fast through all of them, and then we will explain deeply what are the different risks that we have. So in the battery production, we start with the reception of goods. We receive raw material like nickel, manganese, cobalt, and electrolytes. All of this is going to be stored in batches, and here we have, for instance, one general, or in general, we have the risk of chemical leaks and exposure to these chemical components. Then we will start the production of the electrodes, and in this case, all those active materials are going to be mixed, and they will be forming the electrodes, the anode and the cathode. Again, here we can have risk, for instance, of inhalation of those raw materials and causing, for instance, respiratory problems. The next step is then the cell assembly process. In this case, and in this step, the electrodes are going to be assembled into the cells, and the liquid electrolyte is going to be filled inside of the cells. And once we include the electrolyte, we start having exposure to flammable and to toxic electrolytes that will pose additional chemical hazards. Then we have the cell formation or the cell finishing, and here the cells are charged for the first time under certain current and voltage conditions, and this is the first time that we energize our system, so we may have some electrical hazards starting from this point. The next step is the module and the pack assembly. Here the individual cells are going to be connected electrically to form the modules, and then the modules are going to be integrated into the battery packs to create the complete battery system. In these cases, poor connections or for instance having bad assembly process will increase the potential for electric shock and also for fire. And also during this stage, we can cause, for instance, structural damage to our batteries, and this can cause internal short circuits in our battery cells. And the last step is the vehicle integration, when we take the battery and integrate it into the vehicle. And here, errors during the integration can result, for instance, in insulation failures and as well increase the risk of electrical shock as well as arcing, for instance. This is a very fast review of all of the steps on the production, but we can summarize the risk then as it is presented in this slide. So this is the summary of all of the risks that are associated in the different stages of the battery production. First, we have the risks that are associated to the cell production. And here basically when we storage and when we are handling the chemicals like the electrolytes and the active materials, we are posing some hazards to the human health and to the environment. Also, the flammable material will increase the risk of explosion, and especially when we are having them stored and when we are handling them in the production process. During the module productions, this is where the cells are electrically connected to create the modules, and during this phase we will also have some chemical hazards that are going to be caused by the electrolyte leaks, for instance, or to poorly handle damaged cells, as well as we will have fire and explosion risk because of thermal joining process, such as welding the battery cells that requires high amount of heat to weld the batteries and the parts. And also we will have some electrical hazards, including, for instance, short circuits during assembly or storage when we are handling all of this. For example, as I mentioned, the welding process is one of the most critical processes in the module production. Here, any poorly connected terminal could lead at the end to cause sparks, and any of those sparks can cause fire if, for instance, flammable gases coming from damaged cells are present in the air. So it is very important to keep the cleanliness in all of the area and also in the air. And finally, we have the pack production, and here the battery modules are combined to form the complete battery pack system. Some of the dangers that we have here are, for instance, the electrocushions, because after we combine several of the low voltage modules, we activate the high voltage circuits and systems. Also, we have the risk of fires caused by arcing during the final electrical connections that already have high voltage, as well as, for instance, explosion hazards during the storage, handling, and the transportation of all of these packs. For instance, when we are transporting the full battery packs without proper insulations, this could shift to short circuit and subsequent fires. And in these battery factories, when we have a large amount of batteries stored together, one fire is gonna be critical, and it will need to be in general the whole facility needs to be prepared for handling those kind of problems. So to manage those risks in the battery production, there is a need to have a very comprehensive approach that will include technical measures, measurements in the buildings, organizational measures, as well as personal measures. Between the technical measures that we can highlight here, for instance, the facilities needs to include ventilation and extinguishing systems that will control and contain fires or gas leaks by means of having a proper air circulation and fire suppression system, as well as to have alarms that will create warning systems to in case of any of these events, even fire, leaks, or any other hazard problems that we may have. Product-related measures and process-related measures. This is automation in the high-risk task to minimize human exposure to that task, as well as to incorporate safety features in the battery designs, like, for instance, robust enclosures and thermal barriers that ensures the safety of the product and the process and the assembly process. We also have some technical building measures, like, for instance, planning fire compartments in our building, to have rescue and escape routes planning in the facilities, as well as the construction and fire protection materials that are used for the buildings. Between the organizational measures, here we will focus on planning and structuring the work environment to reduce the risk, and some of those are providing to the workers the working instructions and the rules that they have to follow, and that they have to the rules of conduct, Also, structuring of protection and production and company processes, and scheduling of inspections and maintenance in the different stages of production. And finally, also providing to the people the personal protective equipment, and be sure that the people is wearing that, as well as training the employees in the production and in the administration what to wear and when it is required, and to have and conduct occupational medical health examination. These are some of the measures that we can have in the battery production. So to conclude here with the risk in battery production, these risks are going to be ranging from chemical exposure to electrical hazards to fire, explosions, and so on. And all of these required a multi-phased approach to safety, implementing the technical measures, like for instance fire suppression systems and ventilation is needed, but it is also needed to have the organizational planning, such as having escape groups and inspections, as well as to provide the personal safeguards like the personal protective equipment and trainings to ensure comprehensive defense of everybody. By addressing all of these risks proactively, we protect the workers, we protect the assets that are very relevant, and the environment in general. At the same time, we are fostering efficient and sustainable operations in our companies, are creating also confidence in our customers.